Hi, welcome to the class. Thank you for joining on time. I think we still have a couple of minutes before the scheduled time, so we are going to give some time for other students to join in. So maybe another 120 seconds from now, we are going to get started. So in the meantime, I request everybody to go and grab a pen and a paper, or a pencil and a paper, whatever you need. Everybody in the class has to try the questions that we are going to do today. It's you really need something to scribble on. Please, everybody go and get a pen or a paper. Also get a bottle of water if you need, because you're going to have so much of fun, you don't want to miss any part of it. So I think another 30 seconds, I'm going to get started. So many students already joined in. Thank you so much, everybody, for joining. I can guarantee a lot of fun today. Some of you have already taken classes with me earlier, either via webinars or the classes, individual classes, group classes. Some of you already know me. For others, I'm going to introduce myself. Let's get started now. So this is Bhavdeep. I live in the beautiful city of Chandigarh, trying to teach here numericals on laws of motion today. A brief history about me. I did my MTech from IIT Bombay in 1998. And I worked in corporate. Actually, I was in software development for 15, 16 years. And then I was always teaching as a part-time teacher because I love kids. I love physics, and I love to teach physics to the kids, obviously. So like 5 to 6 years ago, I actually quit my full-time job. I tried to go teaching full-time, and there's no turning back. So full-time teacher here at Vedantu, trying to teach you physics today. Helped so many students, thousands of them. And they're not just students. I have taken classes when parents also join in, because they're curious about physics, or they want to learn physics so that they can teach their students themselves. So I have taught physics to all age groups across different continents, different countries. And sitting right here, if your parents, siblings want to join, call them. Your neighbors want to join, call them. So let's get started now with my mission statement. I want to make my student fall in love with physics. So you cannot enforce that. You have to do it with proper kind of understanding with the students. So I try to make my classes fun, and eventually after a few sessions they fall in love. And I have received so many comments from parents saying student was not very comfortable with physics, and after a few sessions it's one of the favorite subjects he has, and that really means a lot. So let's try doing that in today's session. तो आज का agenda, the picture speaks 1,000 words here. Mr. Newton, an apple falling on him. Whether or not you trust the story or not, you understand what we are going to talk about today. Newton's laws of motion. But today, assumption is that you have already studied it from other teachers or self-study or school, wherever, and you are looking for more practice on numericals today. So I'm going to focus purely on numericals today. Right? First law, second law, third law, numericals only. There's a surprise gift coming up for you. Plus, there is a lot of fun in all my classes, so there's no need to mention that. So let's get started with a little revision of the laws of motion. Again, as I said, today's session is not about laws of motion. It is assumed that you're well comfortable with those three laws of motion. I'm going to focus more on numericals, but let's just revise it one time. And if you have attended my previous sessions, I have said one thing, that there are not three laws of motion. There's only one law of motion, right? So second law is the real law, and you can derive the first and the third from that. So basically, in other words, Newton is saying one thing in three different ways. So just one thing, it's just one law of no motion in three different sentences. So can we say that I don't need first and third law? No, that's not right. Because see, in different scenarios, you might be able to use the first law or third law more meaningful. Actually, the words written there are more meaningful. So we are still going to use three laws as long as you understand they all mean the same thing. So we'll start with the first law, that is called the law of inertia, for the same reason that it talks about inertia. Now let's take at this water bottle. Water bottle is sitting here. Nobody pushes it, nobody pulls it. So unless I do that, and the bottle is not moving anywhere, right? So the law of inertia says if something is not moving, unless you push it, it doesn't move. And that kind of makes sense. We see that happening around us, right? The second part of the law is confusing to the beginner. So it says, let's say there is a body that's moving with 5 meters per second. The law says if the body is moving with 5 meters per second at this point of time, Unless there is a force applied, it keeps moving forever. I repeat, forever, with 5 meters per second in the same direction. So if I take this watch, which I love, and if I throw that with 5 meters per second, 100 years down the line, 1,000 years down the line, it's always going to move. It is never ever going to stop. But then we don't see that happening because of, thank you to the friction force. So if I kick a football, the football comes to a rest because there is a force of friction going backwards. So if there was no force of friction, no stopping, right? So that is the first law. Going to the third law, because the second law is more important and most useful, I'm going to spend more time on that. It's called the action reaction, right? So some students who are beginning to learn this, they say, yeah, sir, that makes sense, because if I slap my friend, he slaps me back. That's action reaction, but that's not right. That's maybe taken as a humor, but that's not the law. The law says if I slap somebody, somebody's cheek actually is already slapping me at that point of time. So making it more meaningful, let's say this is my water bottle here. If I push it with 10 newtons, it's pushing me back with 10 newtons, exactly same amount of force. Or let's take more meaningful things. Let's take this mouse here, right? Let's say this is 100 grams of mouse. So it's black color. So let me make a black color mouse here. And I know if this is the ground, if I'm holding it here, the earth is pulling it down with mg, right? So mg is going to be equal to 100 grams means 0.1 kilograms times taking gravity as 10 meters per second square, which is a good approximation. It gives me 1 Newton. So earth is pulling this but down by 1 Newton. Newton says if mouse is pulling the earth down by the earth is pulling the mouse down by 1 Newton, mouse is pulling the earth up by 1 Newtons, right? So then why doesn't the earth move? Because of the same simple reason that 1 Newton is too much for this tiny little mouse and it's too much for the earth, right? It doesn't seem to move. And that's actually always going to happen. So let's say there is a huge magnet here, huge magnet, and this is the North Pole and this is South Pole, and let's say there is a pin here, an iron pin. So let's say, and so many students joined in. Thank you, everybody. Now this magnet is going to pull the pin, let's say with 2 newtons of force. Pin pulls the magnet with the same 2 newtons of force. Even though the pin is tiny, the force is still the same, right? But 2 newtons might be too much for the pin, too little for this, and that's how you see the pin moving, and that's how you saw this moving, right? So that is action reaction. No force is in isolation. All the forces come in pairs. That is the third law. Going to the second law, which is going to be most useful, and today's most of the questions will be based off that. So let's see. The second law says, and most of the students understand this is as F equals ma. That's going to work with 99% of the situations there. But let's still understand completely, and this is where I'm going to slow down a little, because you got to understand the second law in order to do any of the numericals in the laws of motion, right? And as I said, if you have attended my previous sessions, F equals ma is going to be used like thousands of times in next couple of years, and maybe so many times in the rest of your life. It's one of the most used equations out there. You will fall in love with it. So simple, so powerful, yet so error prone, because if you don't understand it completely, F equals to ma looks simple, but that's where most of the mistakes do happen. So let's understand it. Mr. Newton says, first of all, before you understand second law, you got to understand what is momentum. So let's understand momentum. So momentum is simple. I mean, there's nothing much to explain in that. There's a car here. So let's say the car weighs 600 kilograms and it's moving with 2 meters per second, slow speed there, that's fine. So the momentum is mass times of velocity, and that means this is equal to 1200 kilograms meters per second, and that is the unit, right? And it's a vector quantity. That's another area where many students go wrong. If there is another car here and that also has the same magnitude of momentum, let's say it's going in this direction with 1200 kg meters per second, they don't have the same momentum. They have different momentum because one is going east, the other is going west. So you really have to take care of the directions when you're talking of momentum, because there is a change in momentum. If something is moving in this direction, coming back, it's a big change in momentum. It's basically positive to negative, right? So Newton says the rate of change of momentum is directly proportional, and let's forget that directly thing, let's make it equal for now, because as I said, this is not the class in which I'm going to teach you laws of motion. It is assumed that you've already gone through this. I'm just going to cover a little theory on this and then go on directly into questions. The focus of today's class is numericals, only numericals, right? So the rate of change of momentum, what is rate of change? Rate of change means change in something per unit seconds, per unit time, that is equal to the net external force. ठीक है? Now some students are writing on the chat box, sir ये triangle क्या बना दिया? So ये triangle नहीं है, this is called delta. Like we have A, B, C, D's in English, Ka, Kha, Ga in Hindi, Uda, Ada in Punjabi. So this is delta. This is a Greek alphabet. It's called delta, and that means a change. Anything delta, let's say delta T is change in temperature, delta mass is change in mass, delta P is change in momentum, right? Change in momentum pata kara divided by time, that is the force, right? Now you can also write it in two different ways, and I'll explain both ways because some students understand one way or the other. Momentum is mv, right? Assuming mass is constant, which will not always be the case. So you can take this out and say change in velocity by time is acceleration, right? Change in velocity divided by time is acceleration. I'm hoping everybody has done the first chapter carefully. Already know that, right? So this thing can also be written in another way. So mass times velocity is the momentum. So let me complete this first. So this can be written as ma, right? Some students, as I said, understand it a little differently. Change in momentum is final momentum. So final momentum क्या होगा? Final momentum is the mass multiplied by the final velocity, which is usually written as v, right? And initial velocity is usually written as u. I'm hoping again that you have done the first chapter already. So change in momentum is final momentum minus the initial momentum divided by time. And that can also be written as mass can be taken out common here or factored out. And this again comes out to v minus u by t is acceleration. So the master equation here I get is F equals ma, which I said I'm going to use it 99% of the times. Once in a while when the mass changes, you're going to go back with delta P by T, right? So I'm going to summarize all of this on the next page. So second law, the most useful law, you got to understand both ways. First of all, F equals delta P by T. This is what Mr. Newton is telling you. You got to honor him by understanding what he is saying. This can also be written as F equals ma, right? And F equals to ma is what you're going to use most of the times, right? Now jumping right into the questions, let's start the journey, and we are going to do a lot of questions as I said today. So let's start with the very first numerical here. Take your time, everybody. Take your time, no rush. Pen and paper a must, please. Awesome. I already see the answers coming in. So I think I have received at least 12 or 13 answers which are right so far. Couple of them are wrong. That's all right. That's all right. We are going to improve as we proceed with today's class. We are going to improve a lot. Just stay tuned. This 45 minutes of session is going to be really, really helpful for you. Okay. So let me cover the basic concept here. As I said, today's session is all about numericals, but we still have to cover a little theory for some students who don't understand this. Okay. I'm going to cover this theory, and this is the last piece of theory I'm covering, and after this all of them is numerical. So I'm covering theory so that I can explain you law of conservation of momentum. First of all, what is conservation? Conservation is मेरे पास जो है is going to be same. It's not going to increase, it's not going to reduce, it's going to remain always the same. So I usually teach my students conservation laws by making a few objects from our surroundings. Let's say यहाँ पे एक फुटबॉल है, मैन है, एक पेड़ बना देते हैं, ठीक है, साइकिल दे दी इस बंदे को, ठीक है, और भी एक फ्रेंड बना देते हैं इसका, ग्रीन शर्ट पहनी है, फेस का कलर ग्रीन है, शर्ट ग्रीन है, लेट्स से, ठीक है, और एक रेड बना देते हैं, रेड शर्ट पहन ली इसने, एक और बाइसिकल बना देते हैं. Somebody is asking what tree is that? That's, let's say, apple tree. And you can assume any of your favorite fruit. Assume that my favorite fruit is banana, or not banana, actually that's my second favorite. Guava. So let's say guava tree, right here. ये बना दिया मैंने. अब इसके बाद क्या करना है? We have to decide our system. What is a system? Can everybody in the chat box, what is the system? In the meantime, I'm going to draw more pictures here. Some objects around you. पानी की बॉटल बना देता हूँ या कॉफी मग बना देता हूँ यहाँ पे. And all these are out of scale, right? Obviously, coffee mug cannot be as big as house here, but let's say, right? So somebody is writing, and some students are writing. Actually, system is a collection of objects. You're absolutely right. Collection of which objects? I can come and say, oh, this is my system. You might come and say, no, this is my system. You decide based on the situation. As we are going to learn in today's class, you have to decide what is your system. You have to enclose some objects in the system. So मैंने ये decide कर लिया, मेरी choice है. तुम्हें कुछ different करना, you can do whatever. Full freedom for you, right? I decided this my system, but once you decide the system, you have to lock it down. You have to say the system is closed. We are talking of closed system. Closed system में क्या होता है? The boundary cannot be crossed. So this person cannot go and ride the bicycle, right? Similarly, this person cannot go and eat the fruit. No, it's not allowed. Similarly, this person cannot come out and drink the coffee from this mug. ठीक है? This person cannot come out. ये coffee mug कहाँ चला जाता है? Yeah, this person cannot come out and turn the lights on here. It's not allowed. Anything within the system you can do if you're inside the system. If you're outside the system, you don't even matter. ठीक है? Now this blue person can kick the football, he can ride the bicycle, he can eat the fruits, that's all he can do. This red person can ride the red bicycle, green person can fight with him and grab the bicycle, they can drink coffee, they can turn on the lights, that's all right? But since the system is closed, energy will be conserved. मतलब क्या हुआ? इसमें अगर 1000 joules of energy थी, it's going to, it is not going to increase, it is not going to be reduced, it can be converted from one form to another. So person goes and eats the apple, so all the energy in the apple is transferred into the person. Now the person starts riding the bicycle, all that chemical energy has been converted into kinetic energy and maybe into heat energy by friction, right? Conversions will happen, total will remain the same. Now one more thing that we are learning in this year is law of conservation of momentum. So momentum will not change. Delta P is 0. Change in momentum will be 0. This was outer space, बाहर खड़े एकदम, कोई friction नहीं, कुछ नहीं. So if the person kicks the football starts going rightwards, the person starts going backwards with the same momentum, not with the same velocity, same momentum. ठीक है? The football times the velocity of football will be same, and we'll see that. ठीक है? So with that little theory, let's try to do this question. एक बार और करो, like try it for 1 minute maybe. Conservation of momentum. The first thing you do is you always make pictures. Pretty pictures, ugly pictures do not matter. Okay, in the meantime, I'll draw the picture here. So let's say this was the girl here. Yeah, more answers are coming right here. That's awesome, guys. Seriously. Now she's wearing roller skates. Roller skates का क्या purpose है? Roller skates का ये purpose है कि there is no friction. You can ignore friction. क्योंकि यहाँ पे if you go and kick the football here, the football kicks you back, but then you don't start going backwards because friction prevents you from doing that, right? So here we are saying, okay, there's no friction. तो ये क्या है? इस गर्ल के पास ये है, बॉल है, ठीक है? अब मैंने क्या करा? आई विल एनक्लोज दिस एज अ सिस्टम. हाउ मच इज द मोमेंटम ऑफ द सिस्टम? दे आर स्टैंडिंग देयर, स्टैंडिंग स्टिल. सो वेलोसिटी इज 0, सो मोमेंटम इज 0. गर्ल का मोमेंटम 0, बॉल का मोमेंटम 0, टोटल मोमेंटम ऑफ द सिस्टम इज 0. सिस्टम की बात कर रहे हैं, इंडिविजुअल ऑब्जेक्ट्स की नहीं. इसका मोमेंटम निकाला, इसका निकाला, इसका निकाला, इसका निकाला, एंड एड एवरीथिंग अप. ठीक है? अब क्या हो गया इसके बाद? Now this is the girl and the girl throws the ball. Ball has started moving with 6 meters per second. और ball के kilograms था 3 kg. The girl is 30 kg. Okay, let's assume the girl goes in this direction with velocity. I don't know. Okay, these equations and laws are foolproof. I'm playing fool. I'm saying, okay, when the ball goes this way, the girl also goes this way. I can assume that, and the solution will tell me, no, that's right, wrong. It's going backwards. But let's say this is the case. ठीक है? अब यहाँ से थोड़ा स्लो डाउन होके देखते हैं. इसको सिस्टम, ये सेम सिस्टम है, सिस्टम तो चेंज ही नहीं हुआ ना, ऑब्जेक्ट सेम. तो whether the girl kicks or not doesn't matter. Right? The girl can do whatever. It kicks the ball this way, that way, doesn't matter. The momentum cannot change because this is a closed system. किसी ने बाहर से आके बॉल को नहीं फेंका. No external person came in and interacted with the objects here. It's a closed system. तो होगा, अब कितना मोमेंटम है? गर्ल का मोमेंटम है 30v, है ना? 30 is the kilograms the girl has. V is the velocity that I assumed. Plus बॉल का कितना है 3 टाइम्स 8, कितना हो गया 18 हो गया, ठीक है। इज इक्वल टू, इट हैज टू बी इक्वल टू 0 बिकॉज हमने 0 से स्टार्ट किया था, इट हैज टू बी 0. द बॉडीज कैन स्टार्ट मूविंग, बॉडीज कैन हैव मोमेंटम, दैट्स फाइन, द टोटल हैज टू बी 0. अब यहां से तो देखो बेसिक अलजेब्रा है, इसको तो सिखाने का मतलब भी नहीं बनता. तो v इज इक्वल टू नेगेटिव 0.6 मीटर्स पर सेकेंड, ठीक है. अभी नेगेटिव का मतलब क्या है? नेगेटिव का मतलब है आई assume the velocity go to be in this direction. नेगेटिव says no, you're wrong, the girl is actually going backwards, ठीक है. तो अब ये नेक्स्ट क्वेश्चन ट्राई करो, एवरीबडी ट्राई दिस. इट विल बी अ पीस ऑफ केक. केक बाद में खा लेना, अभी लेट्स ट्राई दिस क्वेश्चन फर्स्ट. वेरी इजी, मेक पिक्चर्स, पिक्चर्स बनाओ, पिक्चर्स के बिना नहीं काम चलेगा फिजिक्स में. एनी क्वेश्चन हैज टू स्टार्ट विद अ डायग्राम. You have to draw all the players in there. क्या हो रहा है, क्या बन रहा है. सुंदर पिक्चर नहीं बनानी, आर्ट नहीं है इसमें, टाइम नहीं खर्च करना. Some ugly, quick and dirty pictures, that's it. Meaningful pictures. Awesome. I can see the answers coming in. For the students who are on YouTube, you have an advantage. You can pause it and then you can see it in a slow motion. But that doesn't mean you pause it and make a quick call to your friend or take a break or whatever. Pause the video, sit here. You have to sit here for the whole class, whole session. You will not get a feel of it. ठीक है, ब्रेक लेके नहीं जाना, ब्रेक लेके क्वेश्चंस कर सकते हो पेजेस में, ठीक है. या सम ऑफ यू आर लाइव हियर सो यू कैन इंटरेक्ट विद मी. So yeah, answers are coming in. Good job there. So there is a 1.6 kilograms ball and it's moving with 9 meters per second. ठीक है. अब एक दूसरी बॉल है which is 3 kg ball and it is at rest. अब क्या हो गया? Both the balls stick together. चली मतलब कैसी बॉल है ये, ऐसे कैसे चिपक गई? They are this is stationary, this is moving. What might happen is these are clay balls, right? Clay balls क्या होती है? जैसे आटे की बॉल ले लो, गीली मिट्टी की बॉल ले लो. They will stick together and move as a system. तो ये stationary थी, ये चल रही थी, collide हुई and then इकट्ठे चलना शुरू हो गए, ठीक है. तो क्या हुआ देखो, ये दिखा रहे हैं वो कि question clearly says there is a 6 kg ball here and it collides with the 3 kg ball and they move with some velocity v. जो नहीं पता होता फिजिक्स में, you assume a variable and try to find the value of that, ठीक है. v is a variable here, I have to find it. Same analysis, same approach here, no difference. इसको बॉक्स में बंद कर दिया. क्यों? Some students are asking here, actually I got a comment, sir, why do you take everything in the system? If freedom, why don't I take only one of the balls in the system? You cannot do that. Why not? Can anybody answer me why not? In this scenario you cannot. You're free to do that. You cannot use something here. Yes, awesome job. Because see, let's say this is my system. Let's say I'm saying my system, right? इसमें problem क्या हो जाएगी कि this system then green ball is interacting with it, right? It is coming and colliding with it. अगर green ball इससे collide हो रही है तो उसका मतलब क्या हुआ? ये closed system नहीं है. अगर closed system नहीं है, you cannot use the law of conservation of momentum. Over. There's nothing that you can do. And that is why what I'm going to do is I'm going to take all of this as system and this is again the same system. इससे फायदा ये हो गया कि I can use the law of conservation of momentum. पहले momentum कितना था? 6 times 9 कितना हो गया? 54. प्लस 3 times 0. रेस्ट का मतलब क्या है? रेस्ट का मतलब सो रही है, जो भी कर रही है, आई डोंट केयर, इट्स नॉट मूविंग, दैट्स ऑल आई केयर अबाउट, राइट? बॉल सो रही थी, जाग रही थी, आई डोंट केयर, इट इज टेकिंग अ रेस्ट, राइट? सो 3 times 0 0. टोटल मोमेंटम 54 हो गया. अब कितना मोमेंटम हो गया यार? अब हो गया 9 मास है और v वेलोसिटी इकट्ठे चल रहा है 9 kilograms, राइट? सो नाउ आई एम सेइंग द न्यू मोमेंटम इज 9v. But that got to be same as the old momentum. It cannot change, guys. It cannot, right? It's a closed system. तो v कितना आ गया? 6 meters per second. Isn't it a piece of cake? Tell me. ठीक है. अब हम थोड़ा यहाँ ब्रेक लेते हैं. ब्रेक का मतलब ये है कि let's analyze what we are doing here. Let's try to understand the strategy of solving any of the numericals here. ये रूल नहीं है, कोई रूल नहीं है इसमें, कुछ याद नहीं करना, कुछ मेमोराइज नहीं करना. You have to understand what I'm saying. You can make your own rules, whatever work with you. I usually suggest that you make a picture here, a diagram. अब डायग्राम में ये नहीं है कि अपने पूरा किट लेकर आ गया आर्ट एंड क्राफ्ट का. यू डोंट डू दैट. यू मेक अगली डायग्राम्स, मीनिंगफुल डायग्राम्स. अगली से मेरा ही मतलब नहीं है कि बहुत गंदे बनाने हैं, क्विक डायग्राम्स, ठीक है. सो क्विक डायग्राम्स बना लिया. नंबर 2, ट्राई टू एनालाइज इट. सो डिसाइड योर सिस्टम. In most of these cases you decide your system and then you analyze के लिए क्या होगा? Analyze के लिए you have so many tools here, like conservation of momentum, F equals ma, kinematic equations. याद है वो 3 equations that we are going to use, v is equal to u plus at. So analyze using them. ठीक है, लेकिन फर्स्ट स्टेप शुड ऑलवेज बी अ डायग्राम इन फिजिक्स. कोई भी काम कर रहे हो, तुम इलेक्ट्रिसिटी पढ़ रहे हो, मैकेनिक्स पढ़ रहे हो, क्योंकि पिक्चर स्पीक्स 1000 वर्ड्स. अगर बना दिया ना तो वो विजुअली दिख जाता है. ओ वाओ, ये गर्ल है, स्केट्स पर है, इसने बॉल फेंकी, ये हो गया, वो हो गया. ट्राई टू डू दैट. दीज आर नॉट रूल्स, नॉट रूल्स. ठीक है, ऐसा करके आंसर आएगा ऐसा मैं नहीं कह रहा. आई एम जस्ट गिविंग यू गाइडलाइंस. यू सिट डाउन टुगेदर योरसेल्फ, सॉरी, एंड देन ट्राई टू मेक योर ओन अप्रोच. एज लॉन्ग एज इट वर्क्स इट्स फाइन. ठीक है, कोई हार्ड एंड फास्ट रूल यहाँ पर नहीं है. मजा आ रहा है? हैविंग फन? ठीक है, तो चलो और मजा देखते हैं. ट्राई दिस क्वेश्चन. F is equal to ma, F is equal to ma, easiest rule there. Mistakes do happen. तो एक बार मैं समझा देता हूँ. ये बॉक्स है, यहाँ पे एक किसी ने आके पुश कर दिया 50 न्यूटन से. ठीक है, यहाँ किसी ने आके पुश कर दिया 10 न्यूटन से. अब यहाँ किसी ने आके पुश कर दिया 20 न्यूटन से. द मिस्टेक हैपेंस व्हेन some students say okay 50 10 20 gives me 80. No. Forces are vector quantities. तो जब यहाँ लिखोगे F equals ma, तो उसमें हमने क्या करना है, एक पहले तो डायरेक्शन डिसाइड करो. मैं कह रहा हूं ये पॉजिटिव है, तुम चाहो तो ये नेगेटिवली पॉजिटिव. इट्स योर चॉइस. आई एम टेकिंग दिस एज पॉजिटिव. ठीक है, तो लेफ्ट साइड में नेट फोर्स लिखना है. नेट फोर्स. नेट फोर्स कैसे आएगा? यहाँ पे 50 न्यूटन तो पॉजिटिव फोर्स है, प्लस साइन लगा दो, अच्छा भी लगेगा, इजी भी है. और उसमें क्या होता है ना कि देन यू नो दैट यू हैव कंसीडर्ड द साइन हियर, यू डिड नॉट फॉरगेट. -10 हो गया, पीछे जा रहा है, -20 आ गया. ठीक है, यहाँ तक. लेट्स से 4 किलोग्राम्स का था, इज इक्वल टू 4 मल्टीप्लाइड बाय एक्सेलरेशन. ये करना है. ठीक है, ऑल द फोर्सेस. अगर ये घड़ी है, इसमें फ्रिक्शन फोर्स लग रहा है, ग्रेविटेशनल लग रहा है, आयरन की है तो मैग्नेटिक फोर्स लग रहा है. सारे फोर्सेस को ऐड करके, इकट्ठा करके लेफ्ट साइड में लिखना है. ठीक है, सो दिस बिकम्स 20 इज इक्वल टू 4a. तो इसका एक्सेलरेशन मुझे पता चल गया 5 मीटर्स पर सेकेंड स्क्वायर. ठीक है, अब ये क्वेश्चन ट्राई करो. एवरीबडी ट्राइज दिस क्वेश्चन प्लीज. Awesome. I'm getting so many answers. I mean, this is really encouraging. Very nice. Good work there. Awesome job. चलो ठीक है, इसमें देख लेते हैं. फिर एक बक्सा बना देंगे, बॉक्स बनाएंगे. नो पिक्चर नो क्वेश्चन. सीरियसली, 1 क्वेश्चन 1 पिक्चर, एटलीस्ट 1 फिगर. अनिल का बना दिया. ये अनिल को बना दिया हमने. ये मिस्टर अनिल आ गए. ठीक है, व्हाट आर द प्लेयर्स हियर? नंबर 1 इज अनिल. अनिल इज अप्लाइंग अ फोर्स ऑफ 250 न्यूटन. A friction force जो है that will come in detail in grade 11th actually. So we are not studying friction force details here. But one thing you have to understand is friction force is kind of like destructive force. It's going to waste your energy or whatever. It's going to say if you're moving, I'm going to prevent you from moving. That is the rule you can take. अगर मैं इस डायरेक्शन में जा रहा हूँ, फ्रिक्शन फोर्स विल बी बैकवर्ड्स. अगर मैं पीछे जा रहा हूँ, फ्रिक्शन फोर्स विल बी दिसवर्ड्स. अगर यहाँ जा रहा हूँ तो फ्रिक्शन फोर्स यहाँ लगेगा, उल्टा लगेगा. ये बात बस ध्यान रख लो, और कुछ नहीं समझना अभी. तो फ्रिक्शन फोर्स इज एक्टिंग ऑन द बॉल. दे आर नॉट टेलिंग द डायरेक्शन, बट यू हैव टू नो दैट दिस इज गोइंग टू बी उल्टा ऑफ दिस. हो गया, बस काम खत्म. यही करना है हमने. अब इसका एक्सेलरेशन निकालना है. तो F इक्वल्स ma. कितना F है? F है देखो +250 -150 इज इक्वल टू मास टाइम्स एक्सेलरेशन. ठीक है, तो 100 इज इक्वल टू 5a. नाउ a comes out to be 20 meters per second square. ओवर, खत्म कहानी. That's it. That's all you had to do. Right? I'm not saying these questions will come in exam. I never teach from exam point of view. You understand these questions. All your questions are going to be piece of cake, and we are increasing the level of questions as we proceed in the class today. I'm starting with a basic question. We will keep increasing the difficulty level here. Next question, everybody use your pen and paper please. This is a little trick question. Don't answer that fast because I see 5 answers are already wrong out of 7 answers I got. So 2 students have done awesome job, but others please slow down. आराम से, ठंड रखो, थांबा. ठीक है, देखो इसको ठीक से क्वेश्चन को पढ़ो, आराम से पढ़ो, नो रश प्लीज. Awesome. Many students are giving the right answer now. And I can see one mistake that most of the students who are giving wrong answers are giving. They're not reading the question. I'm going to give you another 1 minute here. Take your time, that's all right. If you have to pause the video, don't go, just sit here, just think about it for a couple of minutes. लेकिन 2 मिनट से ज़्यादा नहीं लेना इसमें. और थोड़ी सी प्रैक्टिस हम करेंगे ना, ये क्वेश्चन 1 सेकंड में ऐसे होगा. लिटरली आई एम टेलिंग यू 1 सेकंड ऐसे क्वेश्चंस होंगे. थोड़ा प्रैक्टिस करना, मैं करवा रहा हूँ, डोंट वरी. ठीक है, हम फिर बनाएंगे, इसमें पिक्चर बनाएंगे. इवन दो दिस क्वेश्चन हैज टू बी डन विदाउट एनी पिक्चर्स, विदाउट यूजिंग पेन एंड पेपर, जस्ट सिटिंग हियर रीडिंग द क्वेश्चन, ऐसे आंसर दिख जाएगा. बट बिकॉज वी आर लर्निंग, लेट्स ट्राई टू मेक पिक्चर टू अंडरस्टैंड व्हाट्स गोइंग ऑन हियर. शॉपिंग कार्ड ऐसे बनाने की कोशिश कर लेता हूँ. आई एम ट्राइंग माई बेस्ट. ठीक है, इसमें हैंडल बना देता हूँ, फिर लगेगी शॉपिंग कार्ड है. ठीक है, अब तो लग रही है. ठीक है, इसमें कुछ रख दिया, आई डोंट नो, सम बॉक्स ऑफ सीरियल्स, एप्पल रख दिया, ब्लैक एप्पल तो देखा नहीं कभी, बट रख दिया. ठीक है, सो समथिंग इन द शॉपिंग कार्ट. एंड दिस इज मिस्टर राहुल. नाउ हिज सन मेहुल, तो मेहुल को ब्लैक शर्ट पहना देते हैं. सो दिस इज मेहुल, एंड मेहुल सेज, and he sees the father is pushing with 50 newtons, and then he says the cart is moving with a uniform velocity of 2 meters per second. Awesome, many students are giving the right answer now. Good. यूनिफॉर्म वेलोसिटी, इसका क्या मतलब होता है? यूनिफॉर्म वेलोसिटी, मैं अभी 2 मीटर्स पर सेकंड से चल रहा हूं, मैं 2 मीटर्स पर सेकंड से ही चलता रहूंगा. Acceleration is the rate of change of velocity. If I'm moving with 2 meters per second with a uniform velocity, my acceleration is 0, guys. This is the key to the question, and this gives you the answer in 1 second. This thingy, uniform velocity. ठीक है, इसको फिर से समझ लो. F is equal to ma. ठीक है, अब F कितना है? इसमें 2 प्लेयर्स हैं, एक तो मिस्टर राहुल लगा रहा है और एक फ्रिक्शन भी पीछे लग रहा है ना, विच आई डोंट नो हाउ मच दैट इज. सो लेट्स से F. I don't know how much it is, but I definitely know it's going backwards. Friction force will always be opposite to the motion or tendency of motion. ठीक है, डिटेल्स में हम 11th में जाएंगे, अभी बेसिक ये बात समझ लो. ठीक है, तो लेफ्ट साइड ऑफ दिस इक्वेशन व्हाट डू यू डू? लेफ्ट साइड ऑफ द इक्वेशन यू राइट ऑल द फोर्सेस. राहुल ने क्या फोर्स लगाया? +50. फ्रिक्शन ने क्या फोर्स लगाया? -F इज इक्वल टू मास. मास कितना? आई डोंट केयर, सीरियसली आई डोंट केयर हाउ मच द मास इज. मास times acceleration. Acceleration 0 है. Uniform velocity means acceleration is 0. So 50 minus F is 0, or friction force is 50 newtons. ठीक है. Many students said 100 newtons. Why? Because what they did is, let me tell you the mistake. Many students did this, F equals ma, and then I don't know what they did. I mean, somehow I don't know what they're doing, because first of all, this is not even acceleration, right? Mass is not given. ठीक है, अब समझ में आ गया सबको. ठीक है, अब as soon as you see zero velocity, or sorry, uniform velocity, you know the acceleration has to be 0. It's a uniform motion. So the net force on the body, law of inertia, what does it say? If the net force on the body is 0, it's going to keep moving with the same velocity. So net force has to be 0. If Rahul is pushing with 50 newtons, friction will push back with 50. समझ गए? मजा आ गया? ठीक, समझ में आ गया एकदम से, है ना? फन भी हो रहा है, समझ भी आ रहा है. ठीक है, बोरिंग नहीं करना है इसको. ट्राई दिस क्वेश्चन, मोर चैलेंजिंग. एक एक स्टेप बढ़ते जा रहे हैं विद एवरी क्वेश्चन. इतनी जल्दी कैसे आ गया यार आंसर? वेरी नाइस. ठीक है, ठीक है. फॉर अदर्स नो प्रेशर, टेक योर टाइम, दैट्स फाइन, टेक योर टाइम. परफेक्ट, वेरी नाइस. ठीक है, चलो अब देखते हैं. इसकी फोटो बना लेते हैं. बॉडी क्या है मेरे को नहीं पता, तो बॉक्स बना दिया एक 2 kg. ठीक है, फोर्स लगा दिया 12 न्यूटन्स. एज सुन एज यू मेक दिस पिक्चर, दिमाग में आएगा यार फोर्स पता है, एंड आई नो द मास, देन दैट मीन आई नो द एक्सेलरेशन. ये सब कॉन्शियस माइंड में आ जाएगा अपने आप. जब कुछ क्वेश्चंस करोगे ना, ये आ जाएगा कि मास दिया है, फोर्स दिया है, एक्सेलरेशन तो आ ही गया मेरे पास, ठीक है। नाउ दिस वाज एट रेस्ट, ये भी सो रहा था, but as soon as you apply the force it starts moving and it moves, let's say 48 meters, ठीक है। हमको टाइम पता करना है, राइट। एंड इफ यू हैव टेकन माय प्रीवियस सेशंस आई ऑलवेज से व्हेनेवर you use these kind of final velocity, initial velocity, you start blindly by writing these 5 letters. Fill in हम कर लेंगे, fill करेंगे values, the values that we know, but you start by writing all these 5 values and then start filling in. Body is at rest initially, so initially this is 0, u is 0, I know that. Then I also know that the body has moved 48 meters, so s मिल गया। ये भी लिखो क्या पता करना है, because then we know which equation to use, so find। Now we are stuck, unless you know 3 variables here you cannot proceed, okay? Every equation uses 4 variables, 3 पता होंगे तभी हम 4th पता करेंगे, तो we are stuck, we cannot move now। But then we go back to the data here, so look at this, you're given the force, you're given the mass, so you can always use F equals ma, so 12 is equal to 2a, so a comes out to be 6 meters per second square। यहां से आ गया सीधा, एक्सेलरेशन आ गया। अब ये कौन सी इक्वेशन है यार, ये तो सिंपल सी इक्वेशन है, s equals ut plus half at square, रेस्ट ऑफ इट इज एल्जेब्रा, मतलब जो मैथमेटिक्स क्लास में किया था वो तो अपने आप कर ही लोगे इसको यार, but I'll still do the complete thing here। So 48 is equal to 3t square, so t square is 16, square root लिया plus minus 4, तो positive 4 ले लिया, काम खत्म। It's over, that's all you have to do। आ गया समझ में? नहीं आया तो एक बार पॉज करो, इसको ठीक से समझाए। आई एम टेलिंग यू अगेन, वी आर टेकिंग लिटिल स्टेप्स। अगर ये नहीं समझ में आया तो अगला और मुश्किल लगेगा, और मुश्किल लगेगा। यू गॉट टू अंडरस्टैंड ईच एंड एवरी क्वेश्चन बिफोर यू प्रोसीड फर्दर। तो लेट्स गेट कंटिन्यू विद द क्वेश्चंस हियर। Yeah, so try this question please, everybody try this question। picture please, picture। अब कार्ड बनाओ, बॉक्स बनाओ, बॉल बनाओ, डजंट मैटर, यू मेक समथिंग। यार इतनी जल्दी कैसे कर लिया यार, थोड़ा टाइम बाकी सबको दो, ठीक है। नो प्रेशर एवरीबॉडी, टेक योर टाइम एंड नो कैलकुलेटर्स प्लीज, नो कैलकुलेटर्स। परफेक्ट, सो लेट्स डू दिस क्वेश्चन। अब इसमें फोटो बनाई, दिस थिंग इज 60 किलोग्राम्स, ठीक है। फोर्स नहीं पता यार मुझे, फोर्स पता करना है, तो आई कैन इजीली से ओके व्हाट्स द बिग डील, एफ इज इक्वल टू एम ए, ठीक है। तो एफ पता करना है, मास पता है, बट now I'm stuck because I don't know the acceleration here, right? But then you can always see, okay, there is some other data given here, somehow I'll be able to find acceleration। Follow the same procedure, I highly recommend you do this। I recommend, I don't say you have to do this because you might have your own procedures there, don't deviate unless there are a lot of mistakes happening, you don't change your procedures, ठीक है। If you are facing problems there, mistakes, errors, you follow this procedure, ठीक है। Now something is moving with 4 meters per second initially, and then it moves with 6.5 meters per second, ठीक है, in 3 seconds। इसका एक्सेलरेशन फाइंड करना है, तो यार वन एंड ओनली वन इक्वेशन, v इक्वल्स u प्लस at डाल दिया हमने। सो 6.5 इज इक्वल टू 4 प्लस a टाइम्स 3। तो क्विक कैलकुलेशन गिव्स मी एक्सेलरेशन इज 2.5 over 3। Now this is one thing I want to emphasize on. Some students start dividing here. You are going to get a recurring decimal and that's going to be really difficult to handle, and it takes a couple of things. It'll take time to calculate that. There are errors that are going to happen because it's approximation, and for that reason I recommend you do not calculate it. Let it be 2.5 by 3, ठीक है, let it be like that, क्योंकि and if you have to calculate it, you calculate at the very end, you plug in this value here, 2.5 over 3, and see, because you did not calculate that, you can cross this out as 20, so 20 times 2.5 is 50 newtons। awesome, हो गया। कितना इजी है, मतलब बहुत, मतलब फर्स्ट ऑफ ऑल नो क्वेश्चन इज डिफिकल्ट, Even if it is difficult, if you follow the systematic approach here, you are going to solve any kind of question. ये last question है. नहीं, you don't need that. Some students are saying, sir, velocity नहीं दिया. How can I find the acceleration? You don't have to find acceleration. Read the question here. नहीं, you don't need any velocity, any acceleration, nothing. Read the question. क्या पता करना है? A clue here is you write the second law of motion as Mr. Newton has given you. No F is equal to ma. F is equal to ma नहीं. थोड़ा हो जाएगा उससे, but it's going to be unnecessary. देखो. Very easy. F equal to delta P by T. ये पता है हमको, ठीक है? तो let's say we have to, क्या पता करना है इसमें? करो, अच्छा करो. Some students are saying, sir, 1 minute. अब हो जाएगा. ठीक है, अब और आंसर सही आ गया. बिल्कुल ठीक है. ये मेरे को फाइंड करना है ना? फोर्स मेरे को दिया हुआ है. और क्या कलर यूज करूं? ब्लैक यूज कर लेता हूं. 5 सेकेंड भी दिया हुआ है. प्लग कर दो यार. बचा क्या इसमें? 50 is equal to that has to be found, right? Divided by the time. No, you don't have to use all the data. Students are saying, sir, 20 kilograms, we have to use that. You don't use that. It's extra information given that you don't use. By 5. So delta P कितना आ गया? 50 times 5, which is 250 kg meters per second. That is all. Right? So now this is a piece of information that was given to confuse you. Many students will try to use that. They think, okay, information given means information has to be used. No. Okay, if the color of the card is given to you, you don't need it, right? The shape of the ball is given to you. Whether it is cricket ball, tennis ball, how does it matter to you? Okay, use the useful information. You have to filter out the information. Okay. So with that said, we are going to end, but I'm going to show the URL one more time. Thanks for your attention. I hope this was really fun, and the regular students plus the other students who joined here for the first time, you're welcome for the free sessions here. We keep doing that. So Vedantu wants to promote free education, and that is the purpose of these webinars. But in addition, there are some courses that also come up as paid courses. You can join them, and I recommend that you join the 2-hour session क्योंकि उसमें और practice मिलेगी. Okay. A nice quote there: don't talk, just act. Don't say, just show. Don't promise, just prove. Right? Now, as I always say before I end the session, this is not a goodbye. It's more like see you soon. Whether in the webinars or paid sessions, I'm going to see you soon.